Okay, looking at lesson 4.3 and 4.5, finishing it up with our last two theorems that prove triangles congruent. We have AAS and HL. And these have a lot to do with right triangles. So just a reminder, right triangle is a triangle with one right angle and the sides of the triangle that make that angle we call the legs. So this would be a leg and this would be a leg. And then the long side of that triangle across from the 90 degrees, so kind of using that as an arrow, is your hypotenuse. Okay. All right, so the first one, angle, angle, side, or AAS. If two angles and the non-included side are congruent, then the triangles are congruent. So that looks like this. So we have a triangle here. So let's say if A, B, C, and then you have maybe D, E, F, and in those triangles you have marked an angle, and then the non-included side. So remember yesterday we had angle, side, angle with the included side. And then over here the same ones are marked. Then we can make the statement triangle ABC is congruent to triangle DEF. Okay, order matters. This is the non-included side of this triangle. So an angle, and then a side are marked congruent. The next one is your HL theorem, which is hypotenuse leg. That deals specifically with right triangles, where you have the hypotenuse and the leg congruent. So again, you have to have a right triangle. So if you have a right triangle, we'll just again call it ABC. And then another. Marked congruent where you have one of the legs and the hypotenuse, right? Not mattering what order, then again you can make that statement. Okay. All right, and so that's pretty much it for your last two theorems. Again, order matters. So let's try a couple problems with those. So decide whether they're congruent. We're going to assume until we prove it that they're not for these. So the theorems that we did in like 4.2, we can now actually determine if they are congruent or not. And then write the statement. So you have to look, do you have enough information? So we're going to combine all five of them, but for right now we're just looking for HL. So remember your reflexive property, Km is congruent to itself, so we know that Km is congruent to Km by reflexive properties. So because of that, we can say now that triangle MKL is congruent to triangle MKN by hypotenuse leg, because we have the hypotenuse here and the leg here. So hypotenuse leg. All right, so moving into this next one, mark any angles, vertical angles, stuff like that, alternate interior if you knew those lines are parallel, things that you know are congruent, and then determine what you have. So we have, I'm going to mark this with 2. We have an angle, and then a side. So it's the non-included side. And so, again, we know that angle BDC is congruent to angle FDE because they are vertical. So then we can make that statement that triangle EDF is congruent to triangle, I started with E, so I have to start with C, BB, by angle, side. Okay. And then just continuing on here, we do the same thing here. Notice this is now our included angle. So we have the side and angle and then a side. So these triangles, so TUV is congruent to WXV by side angle side. So look at the difference here between these two markings. This one has an angle, then a side. This one has a side, an angle, and then a side. So always understanding that matters. Okay, let's talk about this next one here. If I mark everything in this next one, we know these are congruent because they're vertical. We also have parallel lines. So with our alternate interior angles here, we know that D and A are congruent, and then that B and C are congruent. Angle, angle, angle is not a congruence theorem. So these are not congruent. All right, so pay attention to that. Same thing here. We have an angle and then a side and then a side. So these are not congruent because side-side angle is not a theorem. Okay. And then down here, if we separate these into 2 separate triangles, then we know that PR is congruent to SU because this is congruent to itself, so that whole line is congruent. We know that Q is congruent to T, and then we know that T is congruent to U. So we have angle, angle, side. Well, that is a good enough reason to state. So PQR is congruent to UTS by angle, angle, side. Just a couple things I did here. I know that PS plus SR is PR, right? SR plus RU is SU. Okay. I know that PS is equal to RU, and so then I can, by substitution, I'll be able to say that PR is congruent to SU. It takes a couple substitutions, but you can get there with that. Okay, so that's how I was able to mark these down here congruent to each other. All right, so those are our last 2 congruencies. Keep all 5 of them in mind when trying to prove triangles parallel. congruent, excuse me. Have a good night.